Welcome to the next video on separating techniques. We'll be looking at filtration and sublimation in this video. So first up, filtration. It is used to separate insoluble solids or solutes from a suspension. Example, sand and water. So salt cannot be separated from water using filtration. So just a recap of the terms. The solid left on the filter paper is the residue, and the mixture that passes through the paper is called the filtrate. Now, the mixture that passes through the filter paper may not just be a liquid. Okay, so for example, you have a mixture of sand plus salt water. Okay, so what is left will be sand as a residue, but your filtrate actually is salt water. So it may not just be water. So a recap of the experimental setup, you should be relatively familiar with it. The filter paper folded into the filter funnel and placed in a conical flask. So filtration works because the filter paper has tiny holes or pores that we can't see. So these are the pores, so you definitely can't see them, but they're definitely there. And the solid particles that are insoluble are larger. So this is larger than the pore, so they can't pass through the filter paper. But the liquid particles, or in this case, if it's water or even if it's salt water, you might have a different particle there. So both salt particles and the water particles will be smaller than that of the filter paper pores, and hence they pass through. So do write this down, the main concept of filtration, that the size of the insoluble particles is greater than the size of the pores in the filter, and the size of the pores in the filter are greater than the size of the liquid particles. So let's do a short quiz on what the residue and filtrate is in these two cases. These are the answers. Hopefully you got it correct. So a few more quizzes. For those of you who are familiar with cooking, when you use a sieve to sieve out vegetables who are soaked in water, what will be the residue and the filtrate? This is the answer. And those of you who are looking at cleaning the house, if you help in the housework, you should know that this is a vacuum cleaner. And what do you think is the residue and the filtrate? So in this case, the filtrate is actually air, because the air passes through the dirt bag, but the dirt remains in the bag. So remember again, the filtrate may not be a liquid. So when I was living in the UK, I did live there for a few years. I often had to filter my water through a water filter bottle like this. And the water that came out of the taps in the UK was what we call hard water. It contains a lot of minerals, so it's not entirely clear, and you can see that it's a bit whitish. Now, sometimes when I got a bit lazy and didn't filter my water, I could see white solids like resembling chalk accumulating on the metal coil of my kettle. So it would look like this, and that came up from the water. So after a couple of years, I just got even lazier and drank from the taps. So I don't know what is in my stomach now. But we are very blessed in Singapore that our water is what we call very clean or pure. So, what do you think this is? In South Africa, where I went to for my holiday, they've been experiencing a drought for 2 years and they don't know how to purify their water, so they have a big problem. So, let's see what is used for in the video here.
Hey, Tom Shaka here. A couple weeks ago we did a video where we got a grinder and we cut up a Life Straw and a Sawyer Mini, and it did really well. Check it out, it's a pretty cool video. And then Life Straw themselves saw the video and they sent us this clear Life Straw. In fact, let me come closer. I don't want to cut myself out of the camera here, but look at this thing. You can actually see right through it, and you can see the hollow fiber membranes here. So I wanted to do something cool today. Get outside, absolutely gorgeous, loving the weather, it's perfect. So what we're going to do is we're going to dip my water bottle in the stream, or the little lake here. Oh, it's already murky. Look at that. I was thinking of throwing some mud in there. Then I'm going to muck up, then my hands will get dirty, and what the heck. I'll throw some mud and some extra stuff in here. Just clean my hands off. Perfect. Get rid of that. Shake it up. And then I'm going to drink out of here with this clear Life Straw. Right here, I just showed you. And I'm pretty excited to see how it tastes, how it comes through here clear and that type of thing. So the Life Straw, simply just pop the bottom off. I mean, I could just dip down there and drink right out of the stream, but I think this will be more fun. So, simple test, here it goes, drinking with it for the Life Straw, dirty water. And you know what, I want to get closer so you can see this. How's that? Yeah. Oh, so it takes a little bit to suck the water through the membrane, so it's not going to happen immediately. Just keep that in mind. See that clear water? Sorry to spit on camera. Maybe you're thinking it's not appropriate, I don't know. But you can actually see the clear water right in the Life Straw. See that? How cool is that? It's going down now. I'm going to do it again. Swallowed that batch. Tasty. You would think that the water would be nasty, but this, besides filtering it, there's a clear water again, it also improves the taste. I'm assuming it improves the taste. I'm not going to dip my face in that water and see if it tastes any better than this, but that was tasty water. And there, I mean, look at that. That's not tasty water. I'm quite sure of that. So, just blowing the stuff out. By the way, after you use these things once, you don't want them to freeze. It'll destroy them. Think about that. So, pretty neat. I enjoyed that. Clean water right from a dirty lake. Awesome. Life Straw at Camping Survival. Thank you and have a great day.
Now, the Life Straw works exactly like a filter. Has small beads in which the water passes through as a filtrate, but it traps all the dirt in the ground or from sewage. And it's really, really helpful for people who do not have access to clean water. And actually, we are very blessed because 1.8 billion people use a drinking water source that is contaminated feces. So, we have a very, very developed way of purifying our water, including that of filtration, and that's how the South Africans are learning from us now, treating water from the toilet, where we filter all the waste products and bacteria from the sewage water. So this process is microfiltration, where we remove the bacteria and feces. Now let's do a short quiz. Now, why can't filtration be used to separate soluble solids, like salt, from a solvent like water? Now, if you realize, filtration works where the particles are bigger than that of the pores. But if a salt particle is smaller, then it will pass through. So usually solute particles that are soluble in the solvent are too small, and hence they will pass through the pores of the filter paper. Now let's watch this video to see why this can separate salt from water then. Our next technique is sublimation. We have learned this process in lower sec, a process where a solid turns into a gas without changing into a liquid. Now, common examples we should know now are iodine, dry ice, carbon dioxide, which is solid carbon dioxide, and ammonium chloride. So sublimation as a technique is used to separate a solid that sublimes from one that does not. So sublimation as a word means two things. One is the process where a solid changes to a gas, but it's also a technique to separate a mixture of solids. So let's take a look at the video here on the sublimation of iodine.
In this video, we're going to look at the sublimation of iodine. So when we add solid iodine to hot sand, we have a hot plate underneath there, you can see right away we start getting a purple gas. That is iodine gas. And with sublimation, we're going directly from a solid to a gas without passing through a liquid phase. So you can see here that after a while, when that gets even hotter, we get a lot more of that purple iodine gas, which is escaping through the top of the beaker. So we can actually capture that gas. Right now it's escaping through the top of the beaker, but we can put a piece of glass on there, a watch glass, with ice on it. And that's really cold, and that's going to change the iodine gas back to a solid. It won't go through a liquid phase, it'll go directly from the gas to a solid, and that will stick on the bottom of the glass. Here's what it looks like from the top. You can see the ice, the watch glass, and then you can start to see that the crystals of iodine are forming underneath. So after a while, the crystals will have formed on the bottom of that glass, and you can see them here sort of dangling down from the watch glass. If we were to take that watch glass off and look at the crystals, they look something like this. So here in this video, I'm actually taking the watch glass off. You can see the iodine gas escaping, and then you can see those iodine crystals there. So that's the sublimation of iodine. This is Dr. B, and thanks for watching.
So, as the video shows, we can make use of this property to separate a substance that sublimes from one that does not. For example, salt and iodine. So this is what it will look like. The salt will remain as you heat it up in the evaporating dish, and the iodine will sublime, but then again it will deposit. So that's the opposite of sublimation. Deposition occurs. It will deposit again as a solid on the cool filter funnel in this case, or any cool surface they put above it. So to end off, okay, we'll do a quiz. Which of the following pairs of substances can be separated using sublimation? Do complete the following questions as well before class.